ready for takeoff.
So we're going to get started. My name is Andy Maleh, and I'm a senior software developer at Lexop. Lexop is a digital-only debt collection agency. And today's talk is going to be about building native GUI apps in Ruby. But before we get started, I have a few questions to the audience. The first one is, who here knows what a native GUI app is? OK, we have a good number. It's about 40%. By the way, I'm giving away some Lexop swag. As you can see, we have caps, T-shirts. I have a few extra things as well, like Christmas socks. So participation is encouraged. Who here would be willing to tell us what a native GUI app is? Go ahead. Yeah, so part of the answer is correct. We use libraries that are native for the operating systems, and they're precompiled. However, the application that's written on top of them does not have to be completely compiled. So part of the answer is correct, but we'll get into more details about native apps in a second. Why would you build a native GUI app, though? Somebody answered the question. Yep, go ahead, Jeremy. Exactly. We want to build an app that runs without using a browser. Next is, how many people here have experience with native GUI apps or desktop development in general? OK, it's about 30% perhaps. It's a good number. But hopefully we'll get that number higher. So why do we want native GUI? We want to productively build apps that support visual user interaction. So once you graduate from building command line apps, the next type of app you want to build is a GUI app. Build tools to increase productivity, so kind of like IDEs or code editors. Quickly build offline applications that do not need internet. Create online applications for specific users without needing a browser. So you can tailor apps exactly for a certain class of users and make it simpler for them to launch the app without using a browser. Report and summarize data from databases locally, securely. Provide user-friendly, platform-conforming, native user interfaces. Like on Mac OS Ventura, for example, Glimmer DSL for LibUI will run and will look fully native, just like as if you've written the app in Swift, and also on Windows and Linux. Avoid writing many layers of complex web code when you don't need it. Avoid wasting time fine-tuning graphical user interfaces, because usually desktop apps have operating system style guides for how to build them, so you don't waste too much time like you do on the web with CSS. Provide fast performance for graphical control, input-output. So if it's a native GUI toolkit as opposed to a non-native one like Java Swing, it'll have faster performance. However, you can still quickly invent brand new visual concepts for user interaction. So a big misconception is that native apps are limited to native widgets. But that's not true. You can also make your own non-native widgets as well. And also build local games. So here's an introduction to Glimmer. If you just say window open, it opens a window that's completely empty. So it's the simplest syntax possible to open a window. It doesn't get more simpler than that. You add a text, and that adds a title to the window. And then if you want to add a label, you can just say the word label declaratively, and then add a property declaratively within it. And it'll give you a label that says hello world. And finally, you can fine-tune the label by adding a font with a font height. And then you can even change the font height. So it's a very, very simple and productive GUI DSL. It's the simplest DSL possible for going from 0 to GUI. And let's start by talking about real-world apps built with Glimmer. This is Math Bowling 2, which is a kid's math game that adopts bowling rules. Basically, if you get the answer correctly, it's like hitting a strike. If you're off by a few numbers, it's like you missed a few pins when you bowled. So yeah, this is a fun game that I used to teach my nieces, who were 7 years old at the time, math, and it was built with Glimmer DSL for SWT, and it demonstrates that you are not limited whatsoever in the way you build GUIs on the desktop. Are We There Yet is a small project management app that was built for an interior designer to use in their workflow. Again, it's not limited in any way. It includes a Gantt chart. It was built in about 11 days for the MVP, the first version. That usually, you would imagine that would take more on the web. But yeah, it took 11 days using Glimmer. Ruby Radio is an app created by Kojix. That's the nickname of a Japanese developer who builds a lot of, he works in bioinformatics, but he also helps me with my Glimmer projects, and he built his own internet radio app and with Glimmer, and I actually use it as my main app right now for internet radio. This is another app that he built that is basically summarizing his own data from a database locally. He built it, as far as I know, in less than an hour using Glimmer. This is Gladiator, which is a code editor that I've been using full-time for the last 2 years. This is the DCR programming language, Draw, Color, Repeat, which is a kid's programming language based on Logo, which is turtle graphics. And this is a variation on it that uses a stick figure instead of a turtle. This is the bfunc programming language. I built an IDE for it after I discovered that somebody coded the bfunc programming language in a Ruby gem as an engine. So I used that and built a Glimmer GUI on top of it. Solitaire, everybody knows that. Wordle, everybody knows Wordle. This is a metronome that I built for my own uses. I play drums as a hobby, and I need a metronome, so I built my own. And I trust it more than my phone's metronome. And it was built the first version was in 10 minutes, built in 10 minutes, by the way. So what are all the Glimmer GUI DSLs? So we have Glimmer DSL for LibUI, which runs on C Ruby, meaning MRI Ruby. It's in beta mode. And it won the Fukuoka Ruby 2022 Special Award earlier this year in February, after it got judged by Mats, the creator of Ruby, along with other judges. So this is the library that I'll be talking mostly about today. The other libraries that are available are Glimmer DSL for TK, for GTK, for FX Ruby, for SWT on JRuby, Swing, and JavaFX. And the SWT one is the only one that is final. The rest are all alphas, but they still work. So, I mean, the idea of Glimmer proved itself enough that it was worth covering all the available toolkits in Ruby that are actively maintained with a Glimmer DSL. So all of them are covered now. Yeah, we're going to talk about LibUI today. So how do we start? There are no prerequisites. If you have Ruby, you're ready to go. All you have to do is install the gem. And then you can run this command to get started with samples, like to look at some examples. It opens this app that shows you a whole bunch of examples. It's called the meta example because it's a meta, it's the example of examples. And it shows you basic examples on the first tab here, advanced examples over here. So the advanced ones include things like Tetris, Snake, Tic-Tac-Toe, etc. So what are some simple apps? Some simplest thing we could look at is Hello World. We just took a look at it earlier, but this is a cross-platform version of it. Oh, sorry, it's always cross-platform with Glimmer, but this is just showing it to you on all platforms. This is a more sophisticated app that basically lets you store contacts in a sort of a database, and it shows them in a table. Most business apps will have a table widget and will have a form, so this is more demonstrating a more businessy kind of app. And also, you can build games. So as far as Glimmer GUI DSL basics, the first thing you want to learn is controls. Controls are also known as widgets or components, depending on the GUI toolkit you're using. In LibUI, they call them controls. They're basically the basic building block for showing visual concepts on the screen and allowing the user to input or output data. So they usually are declared declaratively. They're in underscored case, meaning lowercase, and the Ruby way of naming methods. And they're actually Ruby methods behind the scenes. And I mean, window, you just say window, and it gives you a window. You say a button, you get a button. You say a label, you get a label, entry, and etc. So there are a whole bunch of widgets. And given that we only have 30 minutes in this talk, I'm going to give you some homework to discover the rest of the widgets or controls. So, I mean, there's this list that has a whole bunch of them, like checkbox, like combo box, form, menu, tab, etc. However, please do your homework. Look at the exhaustive list at the Glimmer DSL for LibUI project page. So the next thing you want to learn about is control arguments. So controls can optionally receive arguments in the DSL. They match the LibUI C API. So for a window, you can pass it a title, like hello world, or you can pass it extra arguments as well, like the width and height when it starts. And that's about it. Next is the control content block. So after you declare a keyword like window, you can open a curly brace block in Ruby. And you want to use curly brace because you're being declarative. We don't want to use do end. Do end is imperative. Leave that for imperative code. When you're in the declarative mode, use curly braces. That's part of the style guide of Glimmer. And you can put within it properties, listeners, or nested controls. So as far as, and also you can pass it arguments, but still open the block afterwards. So as far as properties, you can have things like the title of the window or the content size. And there's a whole list of properties. And again, as part of homework, please go check out the exhaustive list of properties at the Glimmer DSL for LibUI webpage. I mean, properties include things like selected, like the color for a color button, like padded, whether a box is padded, etc. The next thing is listeners. So listeners always start with the on_ prefix. They follow the observer pattern. They're basically followed by an imperative code block. So listeners are the only part that is imperative. Basically what you say is, on closing of a window, do this. This is the time to do imperative code. And within the do end block, you put whatever code you want to do upon closing a window. And same with a button. If you have a button with a title click, on clicked, do this work. And in MVC, listeners basically are, in MVC, are kind of like the controller listening to the view. And when the view gets changes, like a user clicks a button, the controller will get triggered and do some work in the model. So usually this do end block is an implicit controller. It's a lambda, but it's an implicit controller, and it basically will manipulate the model. So you will usually not manipulate the view directly here. Again, as part of homework, check out all the listeners, like on clicked, on changed, on toggled, on closing, etc., on mouse up. And it's at the Glimmer DSL for LibUI website or webpage on GitHub. Finally, the last part in the content block is the nested controls. So you can basically declare a hierarchy of widgets, because in the end, when you open a window, you want to put something in the window. So you build a hierarchy of controls. So a window can contain a button, for example. And in a way, you're following the composite design pattern, because every control that can contain other controls is a composite. And there are a few special layout controls, like vertical box, which lays controls vertically, horizontal box, which lays them horizontally, and grid, which will build them in a grid. And this is a more advanced example where a window has a vertical box within it, which has a label, which has a table, and then the table has table columns. Okay, so the last thing you want to learn as far as the basics of the GUI DSL is the control operations. So they're invoked through Ruby methods on the object returned by the DSL keyword. They match the LibUI C API that's wrapped by the Glimmer DSL for LibUI library. So LibUI is a C toolkit, and that's the one we're using from Ruby in Glimmer DSL for LibUI. It proxy calls to the wrapped objects automatically, so you don't have to worry about it. You just work with the Ruby objects. Behavior is sometimes augmented with smart defaults. So for example, a window, you can invoke show on the window, and that will invoke an operation that will display the window. However, that will also start the GUI event loop for you automatically. Usually with GUI apps, you have an event loop. You don't have to manually start it anymore. It'll start automatically for you. Another example is if you have a checkbox, you can check through operations if it's checked, and then you can programmatically check it if you want. Then you can check again, and it'll be true afterwards. So let's talk software architecture. So the main architectural pattern in desktop apps or GUI apps in general is MVC, which comes from the earliest incarnation of desktop apps or desktop development, which is Smalltalk MVC. So there's a view, a controller, and a model. Usually, the view will observe the model, and then it'll update itself. That's the right way of doing MVC. So this is not MVC from the web, which is a corrupted version. This is the clean, pure MVC on the desktop. You never want the controller to update the view. You want the view to observe the model and then update itself. The controller will observe the view for things like on mouse up, on key up, on click, and then it'll manipulate the model. And then given that the model will change upon manipulation, the view will automatically update itself. So that will, by following MVC, you will have the cleanest, most decoupled code possible. However, a newer pattern that augments MVC is MVP, which is a variation that uses bidirectional data binding. Basically, it upgrades the controller to a presenter that will observe both sides of model and view, and when changes happen in either of them, it'll go and update the other side automatically for you. So it's good to use a combination of MVC and MVP usually in apps. Okay, so let's talk about data binding. What is data binding? So data binding enables you to, with the simplest, most minimal syntax possible, connect the view into the models. So for example, and it follows the way you think about things. So if I have a text field and I wanted to show the first name of a user, all you have to do is use double arrow to say I want to bidirectionally data bind it, and that just leverages Ruby metaprogramming and operator overloading, and it'll basically connect it to the first name attribute on a user object. From that point on, if I update the first name on the user programmatically, like through a controller, the view will update itself automatically from it. And if the user enters text in here using the user interface, it'll automatically update the model. So it's very simple. It's the simplest way to reason about code, actually. And don't believe the React people. They're lying to you. Data binding, bidirectional data binding is simpler than using something that's more like React. So datetime picker is another example. It's data binding the event time on a reservation to the time on a datetime picker. However, sometimes you need unidirectional data binding for properties that are read-only. So a button's text is read-only, meaning the user, when they click the button, that doesn't change the text. But the text will change if the model, if the count attribute on a counter model updates. And you can also add extra options like converters, like on read of the data, I want to convert it to a string. So there are more advanced features in data binding and Glimmer that you could leverage as well. Another example is a label. It's got a text, and you can update it automatically whenever the order, presenter, total gets updated. Here's a slightly bigger example. So this is combining MVC and MVP with data binding. So we have a button counter, click to increment, and when you click it, it'll increment the numbers. So 11 will become 12, 12 will become 13, etc. However, we also have a text field that's data bound to the same data. So how do we do that? We data bind the entry text to the count attribute on the counter model, and then we data bind the same exact attribute to the text of the button. So now they're synced, they're fully synced. And then every time I click on the button, I invoke a listener that will basically, which is an implicit controller, that will increment the count. And once it increments, 11 becomes 12, so then the text field value also becomes 12. However, if the user manually manipulates the text field and makes the value 50, it'll automatically get reflected in the button, and the button will show 50 as well. So this is data binding in action. So again, as part of homework for you guys, check out the advanced data binding features, like using converters on read and on write, using hooks before read, after read, before write, after write, nested data binding, index data binding, key data binding, computed data binding. And all the details are at the Glimmer DSL for LibUI GitHub project page. So, okay, next topic is area graphics. So an area control can draw arbitrary graphics. So the benefit of that is basically being able to build non-native visual concepts. So you can build any concept you want visually using the area control, which is kind of like a canvas, basically. And you can do it with retained mode by nesting shapes directly into the canvas or the area, or immediate mode by using the onDraw listener. Usually, retained mode will give you more maintainable code that's easier to reason about, but the immediate mode will give you slightly higher performance in a few cases, not always, but in a few cases. So you can nest shapes like rectangle, square, arc, circle, line, Bezier curve, polygon, polyline, polybezier, and a figure that could contain anything. So I mean, what you see on the screen here is a completely custom visual concept that's obviously non-native. Like this is not a native widget, but you can build it if you want. You can build any concepts you want. That can come in handy when you're building things like a UML designer, like a traffic signaling app, etc. Okay, so Area will also give you support for drag and drop out of the box in Glimmer, which got added recently. And you get events like on-mouse drag started, on-mouse dragged, on-mouse dropped. And there's an example called shape coloring that lets you basically, using the mouse, grab any shape and move it. And you can see here in the second screen, everything is moved around. Okay, next topic is custom components. So custom components let you build concepts, again, that are not either non-native or they're variations on native widgets. So let's dig in a little bit into that. Usually you would just include the Glimmer LibUI custom control module. It can accept options. And it's useful for specializing controls. So if I want a label to always be red, to use it as a red label, you can make your own red label control and reuse it everywhere in the code. Or you can aggregate controls. So you can make a name and address form, and then use the name and address form in multiple places in your app. The last usage is basically build brand new non-native controls with area graphics. There's also custom windows, which is a variation on custom control that gives you all the features of a window. So I can make a custom window that will open an email, for example, and then you can reuse it multiple times. Or a custom window that's a code editor that you can open it multiple times in an app. And custom windows are also known as custom applications because you can build an entire application as a custom component. So you can include this module or this. They're both aliases to each other. And there are custom controls. The last type is custom shapes, which is an upcoming feature in Glimmer DSL for LibUI that lets you compose any complex shapes out of simpler shapes. And then once you build, for example, a shape called stick figure, you can reuse the keyword stick figure anywhere in your DSL, and it just gives you the stick figure right away with everything you would expect from a stick figure. And you can obviously customize the size of it, the color, etc. So this is an upcoming feature in Glimmer DSL for LibUI, but it's a current feature in Glimmer DSL for SWT, which is the final version of Glimmer. So you just include Glimmer LibUI custom shape. It accepts options. It aggregates multiple shapes. It supports relative positioning, which will simplify the code when you're building them. So again, as part of homework for you guys, I want you to check all the examples that come with Glimmer DSL for LibUI. There's a good list of basic examples as well as more advanced examples like the GPT-2 notepad, which is AI-powered. There's a MIDI player. There's a paginated table, snake, Tetris, etc. OK, so we have a bit of extra time. We have about 5 minutes left. So now that we finished kind of early, I could talk a bit about Glimmer DSL for SWT, which is the finished version of Glimmer that runs on JRuby. So this one is 100% feature complete, and it also includes scaffolding and native executable packaging support, which hopefully should make it into Glimmer DSL for LibUI in the future, but they're already included in Glimmer DSL for SWT. So, I mean, how do we set this up? You have to install a JDK, like JDK 19. You have to install JRuby, like 9380. And JRuby, by the way, is basically a 100% compatible Ruby that runs on the Java virtual machine. That's implemented on top of the Java virtual machine. Once you have the prerequisites, all you have to do is install the gem, Glimmer DSL, SWT, and then you can run samples with Glimmer samples. And it gives you something like this, which is a Glimmer meta sample, which is kind of like the same thing you got with LibUI. But then you have extra things like scaffolding. Like I can scaffold the whole app from scratch, or I can scaffold components, like a custom shape, or I can convert a web app into a desktop app with one command by giving it the website. And it'll basically generate the app directory with the model directory, a view directory, a script to run the app, as well as, let's see, Oh yeah, and you can package the app as a gem automatically. It'll come with the scaffolding, and also it gives you an entry point to the app. So once you have that, then you can do native executable packaging. So from inside the app directory, you can run Glimmer package, and it'll package the app as a native Mac app on the Mac, an exe file on the Windows, and on Linux, like a native app on Linux as well. However, you can customize it. If you want a DMG file on the Mac, you can pass DMG as an option, or PKG if you prefer PKG. On Windows, you can pass MSI and get an MSI installer, official installer. On Linux, you can pass Deb for a Debian package or RPM for a Red Hat package. And it gives you something that's the real deal. It's basically like this is a Mac PKG file of Tetris. This is a Windows MSI installer. So people don't have to, so when you give this to someone, they don't need to install Java, they don't need to install Ruby or JRuby or anything. This includes a packaged Java, a packaged JRuby, and the packaged app files. So everything is self-contained, so when you hand it to users, they wouldn't be the wiser about the fact that you built it with Ruby or JRuby. And this is RPM and Debian packages on Linux. So I want to conclude the talk with a call for help. So here is how you could contribute to Glimmer. You can contribute custom controls or custom widgets. You can build development tools and code editors and IDEs, which are customizable in Ruby, which is very unique. Like if I use right now VS Code, it's not, as far as I know, by default, it's not customizable with Ruby. This will enable you to be able to build apps that are easily scriptable with Ruby. Hot reloading support, WYSIWYG Visual Designer, a control hierarchy inspector, native executable packaging for C Ruby, which hasn't been tackled yet, graphing and charting gems to replace Python in data science visualization. I believe Ruby can do much better than Python, and you can help with that by building graphing and charting gems. Graphical enhancement gems like a shadow system, like a particle system, theming system, etc. And finally, gaming frameworks that uniquely take advantage of retained mode graphics with bidirectional data binding. So most games actually will use immediate mode, and it will give you a sort of a listener that will fire or will render 60 times a second or something like that, or 60 times a second. Here, you can go a level higher than that and just declaratively declare the gaming concept, and they would changes will only happen when a real change in the game happened. So the code will end up a lot simpler by relying on retained mode and bidirectional data binding. Finally, blog and video tutorials. So if you can blog about Glimmer and write video tutorials or general tutorials even, that would be great. Okay, so we have one more minute. I'm going to conclude this, last but not least, with a Glimmer DSL for LibUI competition. That's for RubyConf attendees only, for RubyConf 2022. So basically, build a code editor in Glimmer DSL for SWT. The deadline is January 15, so that's about a month and a half. Hopefully, during Christmas and the New Year, you'll have some time to work on it. Submitted projects are ranked by most feature complete, highest in quality, shortest implementation time. 3 winners will be chosen. All will be mentioned honorably on the project page. 2 of them will get LexUp swag like this for free, and the top winner will get 3 hours of free training in Glimmer from me personally, whether it's a individual or group, if they want to use it for their work group, their work team. And we just need syntax highlighting, editor tabs, open files from file menu, show line numbers, find and replace, indent, outdent, cut, copy, paste, undo, redo, navigation shortcuts, split screen, and autosave. And everything has been posted on my blog, so here are all the links that you should care about. You could take a snapshot of this. My blog, which is andymaleh.blogspot.com, has all the details of the competition, so you could check them later. Otherwise, we're hiring at LexUp. Our motto is work smart instead of work hard, and live well. And if you want to ask me any further questions, please do so after the talk.